Yeah, in this video, we're going to talk about decision trees and about calculating posterior probabilities. Uh, Please note that a decision tree is really a chronological representation of the decision process uh, by a network that utilizes two types of nodes, a decision node, which we represent by a square, and the state of nature node, which we are going to represent by a circle. Also in decision tree, we may or may not factor in the cost of the sampling, which is the additional information. So I have created the two trees, one with factoring in the sample cost and one will not. And what you see here is just a notation. Using the weather forecast, we use WF, don't use the weather forecast. I1, I2, I3, the forecast is the rain, cloud, and sun. S1, S2, S3 are the states of nature. D1, D2 are the decisions to set up and not to set up. The square is a decision point, and the little o is a chance node. Okay? So if we go back to this decision tree, where we basically create the tree going forward and we do the calculations going backward, and actually there's a video shows you how to create a tree using the tree plan, so please, you need to look at that video as well. So this is the part of the tree where we don't use any additional information. So here we have our starting point, and we have two decisions, either to set up or not to set up. And if we set up, we have three states of nature with these probabilities. And if we do not set up, we have three states of nature with the corresponding probabilities. And then if we set up, these would be the payoffs. If the state of nature is rain, we lose 15,000, we lose 5 if it's cloud, and we make 10,000 if it's sunny. If we don't set up, we lose $1,000 in each case. And now we calculate backwards. So this is the payoff with this probability. Payoff times this times this gives me the 3,000. And now this times this times this, and this times this gives me the negative 1,000, which we write here. And so now this is a decision node, so I have to choose between D1 and D2. This one has a higher payoff, so I pick 3,000. So if I don't use the weather forecast, my payoff is 3,000. If I choose the weather forecast, my payoff was this, but how did we calculate that? So now we have a chance node, which is the forecast. So the forecast can be rain, cloud, or sun, and these are the probabilities. If you remember from the calculations, we had about 0.19, 0.32, and 0.49. Now if the forecast calls for rain, I have one of two decisions to make, D1 or D2, and if I have decision 1, then I have three states of nature with these posterior probabilities, and these are the payoffs. And notice here we have negative 16,000 because we are factoring in the cost of the forecast. So we're adding 1,000 to each of the payoff entries, factoring in the sample cost. Same thing here, and same thing on all of these. And now we do the calculations backwards. So this times this times this times this, and we got this number. This times this times this, and this value times this value, we got negative 2,000. So we compare these two, and it's in this case decision 2 with negative 2,000. We do the same calculations here. We create, in this case, forward, we move forward, that's I2, which means the forecast is cloud. We have two decisions, and we have the posterior probabilities for the second forecast. We do the we have the payoffs, we do the calculations backward, and we got negative 1,000. And here, if it's sunny, now we use the posterior probabilities for I3, corresponding payoffs. We do the calculations backward, and we made for I1, if the forecast is cloud, is rain, we lose 2,000. If it's cloud, we lose 1,000. If it's sunny, we make 6,653. And we multiply each one by the corresponding probability and subtract the $1,000. Remember, for the sampling cost, we get 2,560 or 3,560 if we didn't subtract the $1,000. And so in this case, we better off not purchasing that additional forecast. Of course, if I don't want to factor in the $1,000, I just want to repeat this up top portion of this table or of this tree here. So that's what you have here, and you can see here the start by I1, I2, and I3, and I have the decisions. So it's going to be either D1 or D2, and then I have a chance node, and these are my payoffs and their corresponding posterior probabilities. Do the compute calculations backward. So I got 1,000 here, negative 1,000, 0, and I got 7,653, which is the same calculations we had in the lecture notes, and that gives me 3,560. If I subtract the sampling cost, it would be 2,560, same as I had before. Okay. So we talked about computing posterior probabilities. Remember, we had the prior probabilities. We had 0.1, 0.3, 0.6, and 0.2, 0.6, 0.2, and 0.1, 0.2, 0.7. So we're going to compute from these the posterior probabilities. And also we have the sampling, the state of nature probabilities as 0.1, 0.3, 0.6. So we're going to use that for each row separately. So this is a setup that would be very helpful. So that's the states of nature here. These are the corresponding probabilities of the states of nature. This is the probabilities that are given to us by the company that sells the forecast, which is given the state of nature is rain. This is the percent of time the company predicts rain, cloud, or sun, and that's P of I1 given Sj. From these, we calculate the joint probabilities, P of I1 times Sj, which is basically now multiply this times this gives me the joint probability. This times this gives me the joint. This times this gives me this. And now I can compute my posterior probabilities very easily. So first I add all of these, and that gives me really P of I1 for free. And then I take this divided by this. I got my posterior probability for cloud, for rain. This divided by this, I got posterior probability for cloud. This divided by this, I got posterior probability for sun. And then I do the same thing here. So I got those numbers. So I take this times this to get this, this times this to get the joint, this times this to get the joint, add them up, and then divide each one of these by this number to get these ones here. Same thing if I take those probabilities, the prior, multiply them by these ones here, I got those, the joint, add them up to get P of I3, divide each one of these by this to get the posterior. And you can see this structure here really allows you to do this very easy in an Excel worksheet. So this one explains to you, if I went fast over it, what to do in each case to get those probabilities. And actually from this posterior table you can get the summary here. These are the states of nature. This is the sampling probabilities, and these are the corresponding posterior probabilities, and these are my joint probabilities. Means this is probability of S1 intersection O1. That means at the same time. So my forecast is this one, rain, and the state of nature is rain. My forecast is cloud, the state of nature is cloud, would be this. My forecast is sun, and the state of nature is sun 42% of the time. And these are the I1, I2, I3. So that's a summary of what we had there. So which of the, if I have a question, which of the sampling forecast is most accurate? That's going to be P of S3 given I3, which I get that from here, because that's when that gives me the most accuracy, is the highest value here. So that's when, given that the forecast said sunny, I had the actual weather was sunny 85.8571% of the time, while the other ones were lower. Okay, so that's one question you can ask. The other question is, what percentage of time, or the probability that the forecast predicts the weather accurately? So that's for question 2. In this case, we're going to add the probabilities on of the joint probabilities, 0.07, 0.18, 0.42, and that's going to be basically adding those ones along this line. Okay, and this hopefully this should be helpful. The next video is going to be about inventory analysis and how we use inventory models, and sometimes how we can use decision analysis to solve inventory problems. Okay, take care, bye.